Hello, this is Ralph Rio with ARC Advisory Group. Thank you for joining the Digital Twins for Improving Operations and Maintenance session at the ARC Virtual Forum. I'm going to give a short introduction and then we'll proceed with the speakers. First, I will kind of define digital twin and then segment it and then relate it to digital thread. ARC views a digital twin as a representation of a physical system. So you see up in the upper right-hand corner, there is a 3D image of a pump. And that is one way to represent a digital twin, to animate that based on real-time data. Another type of digital twin is really a math algorithm. And that is typically either a physics-based first principle model based on a formula or some math algorithm that is determined by someone who's familiar with the piece of equipment, or it's machine learning that it gradually learns the dynamics of the machine so it can do some asset health monitoring, for example. Now, the primary impediment is for digital twins is data quality, data integrity. So that's why I'm going to talk about digital thread just for a moment. So I'm going to talk now, I'm going to segment digital twins, particularly in the asset management space. And we have major areas of business processes, one around design and build of a plant or an upgrade. We move over to continuous handover, where the new project is turned over to the operate and maintain people, to operations, where they maintain the assets. So within each one of these circles, there is a set of business processes that a digital twin can help out with. In the case of design and build, we see digital twins that typically a 4D model, meaning 3D plus time, and they are used to help out with the construction sequence, virtual commissioning, and operator training. And it involves the ad design and as built for upgrades. And in the operate and maintain side of the world, we see that more real time. Currently, the most common type of digital twin is just the math algorithm, whether it be machine learning or a formula. And that is mostly for predictive maintenance currently, but we're starting to see those applications move into process optimization and energy management. The benefits of these digital twins, the design and build type of 3D, 4D digital twin usually results in shorter product duration because it can optimize the construction sequence. And the virtual commissioning part of it avoids clashes, rework, which also improves the project delivery on time, in spec, and in budget. On the operate and maintain side of the world, most of them, as I said, are predictive maintenance, which means improving uptime or really avoiding unplanned downtime, which improves throughput, capacity, revenue, improves quality and energy utilization. And there is another type of digital twin that is around operator training. So that again is a 3D model, and operators can use that to learn how to do their jobs. Now, just briefly on digital thread, you can think of it as a communication framework for the transmission of data, management of data among many functions within an organization. And that management of the data would be we would recommend it be federated so that there is avoiding data duplication and out-of-date data that's floating around. And we see these three circles here representing three major business processes. We talked about plant design and build and operations and maintenance in the previous slide. Here I'm also adding product design. So the suppliers of the equipment that goes in the plant and design can help optimize the design by having a digital thread that goes from plant design, product design, excuse me, through to plant design and build. And we see an example of that, a rudimentary example, I'll agree, where the manufacturer of a piece of equipment will provide AutoCAD files that define the perimeter of the equipment, maybe connection points, so that they can be easily plugged into the plant design by those people, by the EPCs, to make the plant design easier and faster, but also more accurate. Over in the right side, the product design through to operations and maintenance, we're starting to see product as a service or servitization, where the product design organization, equipment supplier, actually does asset health monitoring in the plant, the user's plant, and provides alerts if things start to go bad. So we can see this digital thread and different types of digital twins in each one of these four circles. Now, the agenda, we're going to have three speakers. It'll be Emily, Joe, and Christopher. They will talk about their digital twins. Some are Emily is more around predictive maintenance. Joe is a digital twin that goes through handover. And Christopher will talk about the plant-wide 3D digital twin for information management, and also some examples of how a remote monitor or a remote individual can participate. Very interesting case stories. And then we'll have a Q&A panel discussion, and their technology providers, Braincube, Hexagon, and Bentley Systems, will participate in the Q&A panel session. And now I'll turn it over to our first speaker. Thank you.
Hello, everyone. So my name is Emily Grams. I am a process analytics engineer at Owens Corning. I've been with the company since the beginning of 2017. Started out as a line engineer and then a shift supervisor. Then I started into an R&D role with the goal of pairing analytics technologies with our manufacturing environment. And I'm here to share with you today a digital twin that we used in a few of our manufacturing plants, and an example of how we applied it. So Owens Corning is a global enterprise with sales of $7.2 billion in 2019. We have roughly 18,000 employees and a presence in 33 countries globally. We deliver a variety of insulation and roofing products for commercial and industrial purposes, as well as residential purposes. We also produce fiberglass composites that are used in everything from cars and bridges to wind energy and personal electronics. So for our digital twin case study, our initial rollout was in 2 of our residential roofing plants. Roofing alone was a $2.6 billion business in 2019. Our shingles are comprised of a glass fiber composite that's coated with an asphalt filler mixture and mineral granules. The plant in this particular rollout produces architectural shingles and a 3-tab residential shingle. Getting into the digital twin, we first investigated potential process twins when we saw a need for our plants and engineering teams to get fast access to large amounts of process and quality data for analysis. We selected a web-based process analytics and management app, which utilizes a structured database. The software we selected served 2 main functions for our operations, so a back-end database with structured process data, and then a front-end analytics package that gave us an ability to identify optimal performance from our historical data and then tracking capabilities to maintain that performance. So the first portion of the digital twin software that I want to touch on is the back-end data structuring process that we went through. So we feed relevant process data from multiple sources, for instance, data from our process historian, and we even feed quality data and COA data in some of our plants. And then what that process model does is it takes that data that we feed it, it lags it all to a common time step using calculated vessel residence times, and then that changes given our process inputs. So what we'll do is we'll feed it level changes, flows, vessel dimensions, and then the process model is constantly updating the lag between process equipment. So if we have a slow time or a downtime, the model will adjust to fit the changing process context. So this will allow us to correlate between process changes regardless of where our sensor measurements are being taken. So once the process data is structured in your database, you can actually begin establishing relationships between process variables and test the effects of input variables on output variables. So within our selected software, we were actually able to correlate a KPI's good performance that's user defined by the engineers in the plant, and then correlate that with multiple input variables at one time using a cross-rank system. So to obtain a cross-rank, the data is placed into discrete operational windows. Then within each window, the software identifies exactly how many points are in that window, and then what percentage of those points led to good or bad performance of our output variable. Input variables that have more points in areas of extremely high or low performance earn a higher cross rank and are more correlated. This method was preferred because it actually allowed us to address some of the challenges you face with trying to find correlations in process data. So non-normality, discrete values, and outliers. The analysis tool is actually able to handle all of those odd things that you'll find in process data. In addition, we're actually able to record these relationships and make set point adjustments or repairs based on how a particular set of inputs have been impacting the output performance of the software. The case study that I wanted to share with you guys. So in one of our residential roofing plants, we worked with the tech leader and we had identified a significant issue within their filler system. So within our process, we mix asphalt with a filler material that's preheated. The plant's technical lead had noticed that in the process, it was not able to maintain optimal temperature for production, despite no apparent change to our settings or startup procedures. What we needed to understand was what had drifted in the coding process while considering any process lags in that correlation. So upon running an analysis, we had noticed that the filler temperature was significantly limiting the filled coating temperature. Then the tech leader actually went back and looked into what led to that lower filler temperature and identified periods of runtime where we were getting little to no heat exchanger fluid flow to their filler heater. Now this was an issue that the tech leader had mentioned would normally have taken weeks to identify and traditionally would not have been noticed by the plant personnel until it was causing significant run issues for their plant. So to resolve this issue, we repaired the mechanical failure that resulted in the upset condition. And then in addition to the repair, we wanted to track these variables to prevent similar issues in the future and further optimize the process if possible. So what we ended up doing was we took those identified ideal ranges for the filler system variables using the analysis module, and now we are monitoring how well we are maintaining these set points, and we're actually able to see the real-time impact on our key output variable of coating mix temperature. So this is different than traditional SPC because we're not just trying to keep track of individual variables' performance within a particular range. We're actually looking to control particular inputs and see how they affect an output, which is the main benefit of using a digital twin to model your process. So outcomes. So what were the main benefits of utilizing a digital twin within the manufacturing space? So with this particular case study, we were actually trying to achieve productivity. We were actually able to achieve a significant materials cost savings. Some additional benefits that we got out of the tool were we found engineers were spending less time actually structuring data for lag times on their own. Normally, an engineer is interested in looking at it. If they're interested in looking at an event and it took place around a slow time, the engineers would have to manually take that into account. But with the process twin, this is already accounted for us. It also increased visibility to what was shifting over time in our processes, and it also helps us capture some of that knowledge from senior engineering leadership. So some of those core fundamental process relationships that we'd like to keep track of, we're actually able to record that and track that in the tool. We also learned a lot of lessons throughout this whole process. So although digital twins are a technology that can be useful in understanding your process, without data gaps being closed and proper maintenance procedures in place, process modeling is limited or not possible at all. You won't be able to calculate residence times if a data feed is unreliable or non-existent. In addition, any relationships that your engineers know exist on a fundamental level will be obfuscated if your data feed isn't kept in optimal shape. We also saw how important it is for facilities to actually have resources to shift from that reaction mindset to a predictive one. It's really hard to think about and optimize for the future if you're constantly thinking about the next fire to put out. So helping plants with this digital transition is going to be critical for any technology that you implement in the future. But I'd like to thank everyone for your time today. Please let me know if you have any questions in the Q&A sessions later.
Well, Emily, thank you very much for that nice presentation. Next up is Joe Guidera, who will be talking about digital twins that go from the design and build side of the world over to the operate and maintain side. Thank you.
Good afternoon. Today we're here to talk about a topic that's somewhat near and dear to my heart, which is building a twin to deliver a digital twin. My name is Joe Guidera. I'll give you a brief background on myself. I'm a project management contractor, have been in the construction and/or projects management business for about the last 30 years, primarily in oil and gas and now in the chemical industries. Currently working with LyondellBasell to deliver a grassroots greenfield chemicals plant and an extra unit in the Gulf Coast region of Texas. I've spent my career in a variety of owner management related roles in capital projects and management as an interface manager, for a brief stint about contracts manager, responsible for technology and telecoms, implementation of advanced work packaging for companies including Hess, Tosco, Phillips, Conoco, Exxon, Chevron, and others. Background in computer engineering and information systems, degrees in business and engineering, and currently engaged as a project manager in the chemicals and energy segment. So talking about digital twins and expecting something different than what we would typically expect has caused us to take a different approach on our project. A little history. Our project made two kind of key decisions that have an impact on what we're here to discuss today. The first was to implement AWP. So it was to be the first use of AWP by the company, and also the first implementation of a digital twin. And so for us, that meant going out and getting some help, because these were both new concepts to the company and to our project. So we sought expertise in AWP from the industry and brought in industry consulting to help us implement and execute on an AWP program. We partnered with an engineering firm that had AWP implementation experience, and we formed an integrated project management team that included a partner with both AWP implementation experience as well as technology experience in building and supporting digital twins. It's a little different for us. So a large group of individuals with very varied backgrounds, but all of which were to help us achieve our goals. Now, we all know, at least in basic terms, what a digital twin is, and there's a definition here for you to see. But part of deciding what the digital twin was going to mean for our project meant setting some very realistic expectations. And so we early on decided that our digital twin that we would hand over to operations meant the ability to intelligently view and navigate the asset that we were going to build. So that meant documents, core data that was identified by operations and maintenance that were necessary for operating and maintaining the plant, a 3D model, intelligent P&IDs, and of course the ability to easily navigate and retrieve that data using a friendly front-end user interface of some kind. Pretty traditional, but very reasonable set of expectations, and also very achievable. And if you know the typical timeline around that, that usually means we start to build out proof of concepts and then start to execute on understanding the exact data needs that we would have. Generally in the detailed design and executing phase of a project, and we don't really start to build out our twin until we start to move away from bulk-based construction into systems-based turnover and completion as you start to bid as-built data. But about a year ago, a little more than a year ago, we sat down in a meeting with the owner, and the owner said, he says, you know, I always thought we're going to have all this really cool technology and I'd be able to push a button and I'd be able to see all these kinds of things. For example, he says, I thought I could push a button and see area XYZ in my plant. And we said, well, yes, that's exactly what you'll be able to do. That's what we're building. We're going to hand that over to you. He says, I don't think you understand. He says, I kind of had a thought that I would have that today. He says, because what you're looking to give me a year or two from now, I really kind of need today in order to help me better commission my plant. So that in this case, the owner and the operations and maintenance team are actually part of the project. They're responsible for the pre-commissioning and commissioning of the plant. And so what they were asking us to do was say, find a way to leverage all the tools and technology, the data that we had collected or were collecting, to find a way to improve not just the project's outcome, but to help them be more efficient in actually turning on this plant. And so we had to take a step back and say, well, we have the digital twin technology, because of course we were going to build that out. And we had a lot of data, right? And one thing we've learned in implementing AWP is obviously it requires a lot of data, mostly focused on construction though, not so much focused on commissioning. And so a big part of this was understanding how do we bridge the gap between the data and the model and the drawings and everything we had that was focused on construction and what was going to be needed to support commissioning our plant. So when we talk about this, he challenged us. We kind of said, well, okay, well, why? Why are we trying to do this? He says, well, he says, you all are doing AWP. And we said, yeah. And he says, and of course, you know, AWP has fundamentally as a goal to improve construction, right? He said, we want to improve time on tools. We get more efficient construction. He says, and you'll shave off days in construction. I said, exactly. He says, well, think of it this way. If we have 1,000 guys working out on the site and you shave off a day of construction, he says, maybe you saved our project $100,000. He says, but if you can make my process more efficient and you shave off a day of my commissioning time, he says, you'll save me $1 million. So what we learned is, you know, $1 of construction is worth a lot more in commissioning. And if we can in turn have better integration between commissioning and construction, I might spend a little bit more on construction, but I'll more than save what I've spent in construction in commissioning. And so who was involved in this effort, right? We had an integrated team that included operations and maintenance, the people who will actually own and operate this plant once it's done. We brought in outside help with expertise in pre-commissioning and commissioning plants. And we started down that journey of bridging that gap between what we had that was in support of construction and what the operations and maintenance team, the commissioning team, really needed to ensure that they could more efficiently turn this plant on in 2022. We started to work hand in hand with those folks, not the usual, okay, you've given us a set of requirements and we'll come back a year from now and deliver, but working day to day to try to understand the problems they were actually seeing or the problems they were trying to solve. And then in turn, learning to leverage what we had in terms of technology and data so that we can solve those problems. And what we started to realize is what they were really asking for was a digital twin. Just a digital twin based on construction and commissioning versus what was necessary to hand over to operations in another 2 years. They need much, much more data in commissioning than they need in operations. If a typical plant may have 100 or 200,000 tags in operations, they may only care about a fraction of those. But in order to commission the plant, they needed to track it all. And they needed to leverage all of the data, not just the data in construction, but the data they were going to need in operations, put it all together. And just like an operational digital twin, they needed to be able to navigate intelligently between the data, the model, the drawings, the intelligent P&IDs, as well as supplemental data that they themselves would bring to the table. By working with them hand in hand, they started to see how I'll use the term, make the sausage. And they realized, wait a minute, can we do some of that? And so we started to teach them how we do some of what we do in building a digital twin, and they started to run with it. So they started to bring to the table things that we would have never thought of, additional enhancements that, had we waited to hand over and then they asked for, might have been expensive to incorporate, but were really very easy to do at this stage of the project. Adding another column of data to something that you haven't yet published is pretty straightforward. So they started to bring in their own people and say, hey, can we take the P&IDs and walk through the model with them to ensure that we can do that what's in the model agrees with the process design and we can make corrections along the way? Yes, you can do that. And we showed them how. So now they had a better representation of what they were going to actually walk down during pre-commissioning. Operations and maintenance would come back and say, well, we saw how you do that. Can you do something like this? Well, yes. Can you tell us what's in that, what you're looking for? Yeah, we can do that. And each time, every week, we'd start to see more and more involvement on the part of the people who were going to use this thing to actually commission their plant and then subsequently use it to operate their plant, which had a huge bang for the buck. They started to incorporate enhancements that are leading to significant efficiencies in the future. It improves what they're going to get at the end of the day. And importantly, as it forced us to focus more and more on the data, it led to better quality, more complete data. Many of us are very familiar with the handover of a plant. We like to say we like to see that garbage truck back up to us and dump off all the documents and data associated with our plant. And then we spend the next several years sifting through it to try to find out, what we're missing and then close those gaps. We're doing that today, and that's leading operations to get something better a year from now. So what kind of benefits can we expect and what kind of benefits are we seeing? First, we started with very realistic expectations. We far exceeded those expectations, in part because we worked hand in hand with the people who are actually going to use it. And they're actually helping us to build it, which leads to a better product for them at the end, and of course helps us to more efficiently execute our project. We start to take the concepts of AWP, which is focused at improving efficiency in construction, and taking that, twisting that, and turning that into, okay, how do we more efficiently execute on commissioning our plant? And how does that in turn drive construction, which of course in turn drives our engineering and procurement? And if we can do that well, I might spend a little bit more in construction, but I'll more than save in what we're seeing in terms of commissioning time. So we see an overall improvement in our project's performance. Every day we have better conversations with construction. We're better able to understand how we can actually visualize what's going to happen, what might be a line in the schedule or a line on a spreadsheet. If you remember that conversation we had with the owner, and he said, I always thought we could just push a button and light up area XYZ. The first time he was able to do it, he said, perfect. We're going to have a talk with construction next week about this because they think they're going to turn that over all at once. And when you saw it and realized that it encompassed the entire plant, you realized that was never going to be realistic. But there was a way to do it, and you could break it down and visualize it, go back to construction to say, this is how we really need to finish the construction and turn it over so that I can efficiently commission this plant. Our delivered digital twin is going to have more value. The data in it is going to be of better quality. It's going to be more complete. And because we worked with the folks who are going to use it, they've identified a number of small changes that we can make today that have huge value for them in the future. And it's very incremental for us to do it now, and so we have. And finally, it improves the adoption and take-up of our digital twin. These are the same people that'll be using it 2 years from now, and they won't be starting from scratch. They'll have a very good understanding of what the tool is, how it actually works and how they can better use it to make their jobs and lives more easy in the future. I hope you've enjoyed today's presentation, and should you have any questions, I'll be happy to answer them in the future at the panel. Thank you.
Oh. Joe, thank you for that presentation. And next, we'll go to Chris Clark, who will talk about a 3D model and also give us a really cool demo of a virtual reality. Augmented reality, excuse me.
Good day, ladies and gentlemen. My name is Chris Clark, Managing Director of Rocket Mine based in Johannesburg, South Africa. And I'm joined by my colleague, Devin Hassenbrook. We're very honored and privileged for your time this afternoon to give you a presentation on how we've been able to take digital twins and integrate with augmented reality technology to come up with a really cool and I guess really practical application of using these two technologies in a real world example. We really, a lot of the focus has been on about what is an actual digital twin, and really where has it been implemented across the world. And I guess if we really start off with the baseline example of a digital twin, it's really a lot more than just a 3D model. Ideally, it's like what you're seeing on the screen here. It's a realistic representation of your physical assets that currently exist, but really adding on information layers and making those physical assets a lot more, let's say, useful, making those physical assets a lot more informative, not just what you see in front of your own eyes, but what information layers can be overlaid right in front of you, kind of like Iron Man style. So, if you look at again, the baseline of what really a digital twin is, it's about in the middle looking there saying, taking an asset, building the 3D model, but pulling in information that already exists in the engineering, operational, and information age. So even your basics, what is about looking at the PDFs that you already have existing from engineering drawings, from any kind of analysis, and combining that static information with what we refer to as that operational or dynamic information, such as IoT sensors, any kind of live feeds that are pulling through, and then giving them a tag, tagging them to each and every individual asset. And a digital twin can be as big as a big plant, as well as go down to a very small asset such as a pump. And how you make that useful can be then exported into many different types of other platforms. And today we're going to be showing you our augmented reality application, as you will, of how we will take some of the static and live information, overlay it on top of our 3D model of a live working plant, and how it can be applied in real time for a person who's wearing today, and what we'll be showing you is a Microsoft HoloLens device in an augmented reality space. Again, a lot of people, when they kind of think of digital twins, and this is kind of our disclaimer, a lot of people and rightly believe that digital twins is really about kind of this level 5 of building predictive and analytical scenarios and planning for digital twins. But to be honest, and we'll be the first to tell you in our experience, is that really customers and projects are really only at the beginning levels at the moment, where it's really about capturing, tagging the information, and then slowly linking the data. There are some very exciting projects out there and different products, but very few people have been able to really kind of pull this all together to get to the true level 5 scenario. So today we'll be getting up to this level 3 of what you see on screen, which is to show you the progress of how we've gone about capturing an information and telling you the story about what we've done in doing a simple asset tagging of some assets on a brownfield plant, and then putting through the live information on an augmented reality device. So how we as RocketMine got into this journey of taking digital twins and augmented reality and combining them together is that we are predominantly, or started off as a drone data acquisition company based in Johannesburg with branches in Ghana, West Africa. And we had one of our gold mining customers in West Africa give us a call and say, look, I'm really, really struggling to be able to get my expats onto site. You know, the local governments won't give expat visas, but we need to get our engineers in Canada and UK to be able to get access to the sites in this case Ivory Coast. And that really kind of sort of piqued our interest. Already we had guys on site flying drones, creating 3D models and orthomosaics. But now we needed to be able to extend that reach to allow this live information and for engineers in the UK and Canada to be able to assist those on site when you know what I mean, to allow for that kind of help. And this is really the concept that we came up with, and we started going on a work of building a proof of concept around digital twins and augmented reality. So what we then did is we went ahead and using a software platform called Bentley PlantSight, is that we used our experience in the drone industry to create this 3D model and essentially build this digital twin on the Bentley platform as well. The really great thing about the PlantSight, what we found is that it really allowed and had the APIs and the SDKs available for us to again not only put the model on, but to also be able to pull through and simulate data as well. So to give you a quick example, so we took a drone and using photogrammetry, we're able to model this processing plant on one of our customer sites. It's a platinum mine. You can see the sort of the level of the detail that you can get, and you can drill down. So you can really start off quite large. So what will happen is that we would go out, use a drone, do some photogrammetry modeling, build these 3D models, and then upload this into the PlantSight system as well. Then the idea is that once you've created the actual model itself, you could then go and start doing all the asset tagging. So in this particular case, you can start really sort of taking your assets and really start pulling through the information in each of these assets as well, and linking the critical information. So the idea really is that to make a digital twin useful, you're going to start overlaying the first bits of information and pulling through the dynamic or the operational info, and then start setting your alarm systems and sort of boundaries. And as you can see here, you can really draw around a particular asset. We've sort of set an example here of a particular asset and sort of triggering off the events. And the idea is that once in a web version and sort of this 2D, let's say, a setting, once you've seen this in sort of 3D and you get this alarm, the idea is that you then want to be able to dispatch a technician or an engineer to the actual assets, who's then going to be able to fix it. And we want to be able to not only again give the expat who's sitting overseas not only just the 3D model, which can be updated on a daily or weekly or monthly basis, but you also want to be able to give them the context of now what's happening on ground. Now that there actually has been an alarm that's gone off, a trigger has happened, what do we do now? So we take it one step further, and this is where now the Microsoft HoloLens device and augmented reality now comes into play. The whole perspective was to go out, capture the whole entire area, tag particular assets, attach them to alarms or IoT or monitoring systems, and we would then, you could then monitor them, right, from a control room, what we like to call kind of a shared engineering service, so very similar to how finance and IT and all the services have these sort of shared service desks. You can have that with engineering. And once you'd have an asset that would trigger off an alarm, you would then dispatch a technician or engineer who would then have to go and perform a routine procedure, right, on a particular asset. And this is now how we now integrate the artificial reality.
Yeah. So basically, this is what you're seeing now is exactly what I'm seeing through the HoloLens. So I do have the device on, and I've got this little drone in front of me here. So what we did in lockdown period was that we modeled this drone. So what it means is that, well, the theory or the thinking behind it is that whenever you have a task on site that there aren't, sort of engineers or anyone that's trained to do the maintenance or upkeep of a certain piece of equipment on site, you can build these sort of animations on how to get this project done. So what we've done is it's just a little how-to video on this drone, how to put it together. It's a few simple steps, but obviously this can be extrapolated to any engineering piece of equipment. So I'm going to go ahead and get started. Yep.
Sorry, do you just take a step back? Sorry, so we can just see everything. And just the drone. So yeah, perfect.
Okay. All right, so you can see here in front of me, I've got all the tasks to set this drone up. And what I need to do is just click on the start button over here. So I'm going to go ahead and do that. And all I'm going to do now is just follow the animations that we're seeing on screen here. So the first one, it's asking me to put the memory card in the drone. So go ahead and do that. And when I finish the task, I can just go ahead and click next. And it'll just take me through the steps here. Another interesting thing is that the drone is, or the digital twin here is pulling through the live battery log of this battery that's in the drone, and you can see it's sitting at 3%. So I can just go ahead and I'm going to that one out. And then just follow the prompts and put the new one in again. Charge battery. So I'm going to go next. You can see now the battery is sitting at 98%. So it's pretty good. Next thing is to just turn the drone upside down. Just need to remove the protective cover. Just click and guess once I finish the task. Another cool thing is if I want to replay the previous step, I can go and click no replay here as well, and it'll take me through that previous step. Let's open up the drone arms over here. So yeah, you can really see it's just nice and easy, and exactly what you're seeing, I'm seeing as well. Open up the pillars. Yeah, it's asking me to turn the remote controller on. Done that. Click next. Drone upside down. Check the battery level. Yeah, turn it on. Okay. The drone back down again. And that's it. Drone setup complete. Go ahead and go fly. I'll just take you for a walk around the office here. Okay, let's just drop you there.
Great. Perfect. Devin, let's perform as an example, we're gonna sort of, we're in COVID, so we're all kind of like locked in our buildings. We can't be at the plant right now, but we're gonna, I guess, perform a complex task, right? You kind of followed that procedure using augmented reality. You didn't come right. How can I assist you today?
I really want to turn the aircon off. If you can help me with that, please. And the dial is here right in front of me.
Sure. Just so we're clarifying, we're going to be looking at this, these two over here. I'm just going to just want you to go, just to have a look a little closer at this for me, if you don't mind, just going a little closer. Yeah. You see the red circle there?
Yeah.
If you just go a little bit lower for me, I can just have a look. Thank you. Yeah. And I'm just going to put a little arrow here on this button there.
Okay.
You can press it, and that's That's on and off.
Yeah.
Perfect. I'm going
Great.
to clear that. This is purely about taking something really, really large, doing the 3D model, but making a digital twin practical today. Because while digital twins are really expected in the near future to be able to offer this level 5 of predictive analysis and sort of self-correcting sort of formulas in the world, we really wanted to say, well, how do we take where the world is practically at a level 3 in a digital twin, but and make it useful on site today, not only for remote engineering services or remote assistance, but also even in a COVID world, when necessarily not everyone can get onto site, you can't have too many people on site, and we can collaborate. So, Devin, I don't know if you want to just quickly maybe just show off, maybe just going through the XR10 device.
So this is the Trimble XR10, which is essentially a hard hat, a Trimble hard hat, and a Microsoft HoloLens 2 device built into it. This is obviously the augmented reality goggles, or that sits at the front, and at the back you've obviously got the PC or the computer and the battery that sits over here. There's also this device at the back here called a Mobilis, which is essentially these little vibrating pads which sit just behind your eardrum on the sort of the solid part of your I don't know what the right word is, the cranium of your head, I guess, and it vibrates through that, and that's where the audio comes through. So what happens is, as the vibrations come through, you can hear still with hearing protection on as well. So if you have any hearing protection on, you can still hear everything loud and clear. Yeah, you can obviously also lift up the goggles if you want to have a normal view, and you can obviously wear this in any site. It is obviously a hard hat. So
there you go. Great.
Appreciate it. Thank you, guys.
No, thank you. We really appreciate it. Ralph, thanks again for the opportunity.
All right.
Thank you, guys.
Thanks, everybody.
Thank you.
Cheers, guys.
See you, Ralph.
Bye-bye.
Bye-bye.
Well, now we're ready to move into the Q&A session and invite the speakers and panel members to turn on their videos. Chris Clark isn't able to turn on his video. Evidently in South Africa, he's having a power outage, and we can get his video, get his voice, I think. Maybe not. I see he's not going from unmute, but he's in the middle of a power outage. Maybe we can get his audio later on. So thank you for those great presentations. You'll notice that there are a few more people than just the speakers here. So to start this off and kind of introduce the technology providers, I'm going to ask each one of them a question. The first one is to John of Coppola, Braintree. And I just, that Braincube, excuse me. Braincube appears to be more of a general purpose tool. I'm assuming it's used a little bit beyond just glass manufacturing. Could you talk for a moment about what other industries you play in?
Yeah, sure. So Braincube isn't segmented to a vertical within industry, as Ralph alluded to. We focus today in a number of different verticals, not limited to building material, food and bev, chemical, pharma, glass, oil and gas, paper and pulp, CPG, auto, et cetera.
Oh, excellent. Thank you. Thank you. And a similar question over to Mike with Hexagon. Beyond Joe's example in the oil and gas design and build, are there other industries that Hexagon is used in?
Sure, we've got a really broad portfolio, and historically we've been in that design phase of the project, but we've expanded our portfolio over time. So now we go from early on in the assess phase all the way through to the operate and maintain phase, and we're in multiple verticals. Traditionally, we've been oil, gas, and chemical, but now we've got a footprint in food and beverage, mining, manufacturing, pretty much you name it.
Nice. All right. And Anne-Marie Walters with Bentley Systems. Chris did a nice demo there of your software in an oil refinery, I believe. No, mining company.
Mining.
Yes, sorry. what other industries I'm sure you do more than just mining?
We certainly do. So Bentley basically supports what we call the infrastructure, the built world. So, and we're focused on ensuring digital twins are used across all of infrastructure. So in the industrial sector, we're talking oil and gas, chemicals, process manufacturing, discrete manufacturing and mining. In utilities, water and power generation and transmission and distribution, transportation, roads, bridges, highways, that kind of thing, and digital cities as well, and the cities environment. And we're very happy to be involved next week in ARC's Digital Cities forum as well.
Yeah, I know you're very big in infrastructure. Yes, excellent, excellent. So this first question I think is that came in is to Emily. So it's about who monitors what's going on in the Braincube and reacts to set point deviations or process upstates and stuff like that. How does that part of it work?
So good question. I think the main goal would be to have a feedback loop between operations and the technical team on site. So the operations team would monitor the data and the output variables performance and Braincube actually does have a ranking system. What's the most important thing to look at in the process? What's underperforming currently? So ideally it would be the operations team would see what's not running well in the process. They look into the set point variations, see if there's anything that they can do on their end to get the process back into alignment. If there's an additional variable that seems to be unaccounted for and they need additional assistance, they can bring that up in a huddle to the technical engineering team. We're also looking into incorporating some sort of digital engineering team on site with the plant team themselves. So having that remote network to kind of connect the dots between kind of the old operational process of manufacturing with this digital transformation with Braincube.
Okay. It sounds like it's mainly then a offline analysis tool rather than a real-time online used by operators. Is that right?
No, actually it is a live data feed. And
okay.
There is like an operations view for operators as well that it offers. Right now we're currently using mainly like shift leads and the leaders of the operation team for this, but we would like to implement it in the future using the broader operations team.
Okay. John, if I could ask you to chime in, I'm sure you're familiar with other counts other than Owens Corning. Could you talk a little bit about how is what Emily's doing typical or is some people more real time or more offline analysis? Could you talk about that a little bit?
Yeah, it depends on the actual need of the customer, which is what I think you're alluding to. And when we look at the majority of our customers, they follow a very specific process that we implement from a consulting standpoint that takes them through we offer a lot of applications from general dashboarding to the more advanced apps, which Emily is talking about. And the hope is you want to have that feedback loop, as Emily had talked about, where the set points or the range is staying in compliance down at the operations level. So what we offer is something called Braincube Live, which would be a live dashboard, where after the analysis is run and with management approval, you can deploy the findings down into the operations level so they know how to maintain the standards set forth. Where we're going as an organization in the future is to actually bypass the operator and connect right into the PLC layer so that Braincube is making the change automatically. We're not there yet, but hopefully very soon.
Okay. All right. Good. Oh, just Emily, a follow-up question. How are people notified that something isn't going right? Is it somebody looking at the screen and noticing it doesn't go right and then alerting somebody, or is there some automated alert system that you're using?
So we do have So there is like a dashboard screen that kind of like alerts you with color indication of when something is not right. And then they also do have alerting features that we've set up on one of the plants. So like if it does go out of spec, it'll send like an email alert to the appropriate personnel, like who need to get that alert, as opposed to it just get sent to everyone. So the actual people that can do something about that do get email alerts for that particular process monitoring system.
Okay, all right, thank you. So I think this is for everybody, and it's, the question is around what's the impediment for implementing a digital twin? And I've noticed over the past couple of days that there's some discussion of, I happen to think it's mostly bad data, but others think it's more around integration and being able to get the data from other applications. So perhaps someone would want to talk about that a little bit. We've been asking all questions of Emily, Joe, or Chris. Chris is on mute. I don't know if he can get in. Maybe Joe wants to chime in on that. Is kind of talk a little bit about the impediment to implementing a digital twin.
I think from an implementation side, I think you're really right on in both cases. Obviously, one is having the data that you need with the quality and completeness that's necessary to really do it effectively. And then oftentimes, when you think about what we're doing in the completion space, is not even really part of the primary project, right? That's usually its own little project that's kind of coincides with the main project. So there's a degree of integration there that is often lacking. So improving either or both of those things allows us to better do this. So, we've consistently said over the last two years or more, it's all about the data, and I don't think that's changed.
Any of the technology providers want to chime in on? Go ahead, Anne-Marie.
I'll chime in if you like, because I think what we're seeing with the advent of digital twins and the ability to pull data in very quickly using cloud computing and things like that a lot of the participants have spoken about over the past couple of days. You have this ability to pull all this data together. Everyone working with data hasn't got bad data. They've got the data that they want for their job, and it's usually pretty good, especially if the frontline workers are using it regularly. What a digital twin environment allows you to do is pull all of this data together and sort through what is really useful and what is really what's needed to make those decisions more valuable to everybody. So we're seeing, as people have don't wait until you've got good data. Start with the data you've got, and then the process of pulling the data together will help clean up that data. We're seeing a lot of our users are having tremendous benefit by starting this process and then focusing on the data that really matters and cleaning it up as it goes. And especially if you've got a web-based system, you're able to connect remote workers together, like has been the need. You find that this data will get cleaned up. People will say that is wrong, you need to update it, etc., etc. So I think that's very much part of what the digital twins are doing, and integrate, and by pulling everything together in context, you don't necessarily have to have everything completely lined up. It will get aligned.
And I'd actually agree with you, Anne-Marie. I think the process twin specifically that we bring to the table, a byproduct of this that we've seen over the past couple of years is while you can identify gaps where you don't have data, organizations are actually utilizing that as value, because now they've understood, okay, we have a gap here, but what are the types of instrumentation or sensors that we want to implement to ensure that we have more value out of the digital twin in the future? So it actually can help you if you look at it in that way.
Excellent.
I could also add that, a lot of our customers don't have data, right? They're still dealing with the low maturity, to Chris's point, of documents and unstructured data. And so getting that data, or getting those sources of information converted into data, is a major challenge and requires a lot of thought and effort to do.
I would add, though, that there's a lot of, that's where artificial intelligence and machine learning is really coming into play, being able to take a whole pile of unstructured data and add some structure to get to it, as it, for example, reading P&ID, unintelligent P&IDs, recognizing the tags, but also the symbology, and being able to create that data model. So that's where we're seeing a lot of those tools being used now to create structure from unstructured data.
Yeah, I agree.
kind of summarize the data quality issue. It shouldn't be an impediment to getting started. It should not be an impediment to get started. But you may want to add some time in your project to recognize that you're going to have to deal with some data quality issues and fix them. So there may be add some project implementation time to your schedule. That kind of approach. Yeah, this one is Chris, for Chris. And he's off mute, so I'm assuming he's got audio for a moment. Are you there, Chris?
Yeah, Ralph, can you hear me?
Yes, I can. Good.
Hey.
Great.
So
it's the realisms of living in Africa. So we got real problems to solve, and with the
well, the question is around how real time is the data generated being modeled? Is it live? Considering the constant changing of information that the drone is generating, how does that impact the model? You mentioned you're using photogrammetry. How often, I guess the question would be, how often is the model updated with acquiring new photogrammetry?
Yeah, it's a very interesting question, Ralph. And I think it's also just important to probably also try and draw the line between what is, let's say, building information management. So let's say a greenfield site under construction, and you need to be monitoring and comparing sort of planned versus actuals, right? Of a model of a site versus the sort of the CAD drawings. And when you specifically looking at brownfield sites or completed sort of plants and installations and implementing a digital twin. Now we've done both and done both sides, and we've sort of followed this customer journey where they've wanted to use BIM or building information management, and then convert over to the digital twin process. So you kind of use a lot of the data that you generated while the site was under construction in implementing going forward. But speaking around the photogrammetry, and I also see there's a couple of questions around sort of LiDAR and laser scanning. And it's really about, a horses for courses approach, because you're right. What do you really want to measure? If you want to get down to the nuts and the bolts, and if you want to start putting information layers on really small assets, then yes, we're going to get down to sort of laser scanning the entire plants and even combining that with the photogrammetry models. But if you've got sites which are constantly changing and you need a fast turnaround on the models of the data, then generally photogrammetry does offer quite a nice, let's say, advantage with that as well. So we've seen both, but the nice thing is we're using drones and drone technologies that you can capture large areas relatively very quickly and produce those sort of level 1, level 2 data sets, within sort of a week.
Excellent. And yeah, okay. The next question is about the user interface, and at least the person who entered the question has a perception that they're not very flexible, so maybe some of the users could talk about that a little bit, about configuring the user interface to fit the needs of the operators on the plant floor, perhaps. Emily, would you? I'll put you first up. Put you on the hot seat.
Yeah, so we did have a lot of challenges with that, just because with some of our traditional, when you implement a data historian, people get used to looking at that data historian, people get used to looking and consuming data in a particular format. Getting them to transition and understand that new user interface can present some challenges. So a lot of times we'll like take feedback, and the nice thing is that if we have feedback about how the user interface can be improved, we do usually submit improvements since it is a subscription service. And sometimes we can get those things corrected to fit our individual needs. Other times it could just be trying to organize the data based off of the functional locations that already exist in the plant. So making sure that we're organizing our data correctly up front. So it's easier for them to actually see, oh, I understand that group location. I know what the coder is, and I can actually see that group of variables more easily. So really focusing on like organizing your data was something that helped us. And then also just sending that feedback and trying to work with the digital twin producer and get those needs addressed.
Thank you. Thank you. Joe, you're serving two very diverse populations, I think, one around design and build and another one around operate and maintain. Now, I know your digital twin isn't quite yet into operate and maintain yet, but could you comment about the flexibility of the user interface to be able to serve both audiences?
Both of them want to be able to visualize. They're just interested in visualizing something different. Operations obviously is more about having certain pieces of data at their fingertips. And so the user interface really reflects that concept, the concept of being able to go after based on something I know or something I see, and then from there to navigate to the other pieces of data that I either need or to the operation that I need to take. So that interface really helps with that aspect. When you're looking at it from a design and build perspective, they're looking more around, well, what's this particular piece of scope that I need to build, or that I need to package, or that I need to complete, or I need to test. So one's kind of almost looking at it at a very microscopic view of, here's what I'm going to do over the next week. And another one might be looking at everything. Okay, if you put that all together and organize that by the way that I'm going to inspect it, or I'm going to lock it and tag it out, or I'm going to walk it down, or something else. They're looking at the same thing. They're just looking at it very differently.
So if I could just follow up a little bit, AWP, there may be some people in the audience who are not familiar with the terms or practices in the design and build. Could you just give a sentence or two definition of AWP? You talked about that a lot in your presentation.
Sure. So, fundamentally, what we do is you essentially go ask construction, or if you're going to build a house, you go to the constructor and you ask them, how do you want to build that house? And based upon how they actually want to build it, we'll then go design it and buy the materials and equipment necessary to give it to him so that he can build it in the order that he wants to build it. As a result, obviously you get efficiencies because you're now not scrambling around a plant doing anything that I can just because that's the material I have on hand or the engineering that happens to be complete. You're delivering in the sequence that the guy who wants to build it says, I want to build it. And then you manage constraints around what are those things that are preventing him or her from being efficient in the field.
Yeah, I understand that that's called a advanced work package. Is that what
Yes.
AWP stands for? Yeah.
Yes.
Okay. And is that something that is facilitated by the digital twin that Bentley Systems is providing?
In our case, we're not using Bentley.
Hexagon, excuse me. Yeah.
Hexagon. However, yes, a big part of advanced work packaging is workface planning. So it's how you actually break down the work into smaller chunks of work that can be efficiently executed by a crew in the field over a span of about 2 weeks. And using the model to visually create the work or the work packages allows the constructor, the area foreman, the general foreman, and the like, and the craft to look at it and say, okay, this is how I want to go execute it. Planners, I want you to go grab that and put that in a package. So today we can do in planning in a span of minutes or hours what might have taken days or even weeks to do, not so long ago using the software.
Thank you, Joe. Thank you.
You're welcome.
There's a question here around standards for digital twins. I understand that. I forget the name of the group off the top of my head, but there is a group that just started a couple of months ago, starting with standards, trying to so digital twins can communicate with each other. But I was wondering if anyone would like to comment about standards that they're involved with for digital twins. I see Anne Marie went off mute. Go ahead.
So, as with standards, there's quite a few standards bodies, and I've actually seen a big explosion in interest and renewed interest again, especially from the oil and gas industry, but into standards, because it's all well and good you combining information together and then sorting things out, but if you can ask your supply chain for the right information for you that's going to be useful to you, and it's all the same whether it's Exxon or Shell or BP asking for it, it does help the supply chain big time. So, but there's a couple of standards organizations that we're involved in. We're involved with Microsoft and a much broader thing called the Digital Twin Consortium, and that's all about trying to combine different types of really different types of use cases across the whole gamut, from financial digital twins, operations digital twins, supply chain digital twins, to be able to combine those together at a platform kind of level. That's the Digital Twin Consortium. And then in the oil and gas industry, there's groups. There's a group that's focused on handover, CFOS, which is part of the International Oil and Gas Producers Organization now. They are they're very much looking at the digital twins environment for particularly handover, basically. And then you've also got the operations and maintenance area. There's it's a consortium with the Mimosa organization, IPA, the Institute of Electrical Standards, whatever that is in the USA, and they have an initiative for open interoperability ecosystem, basically, and they're pushing along an ISO standard for data exchange at a digital twin level, which is ISO 18101. So,
when you start quoting numbers, my eyes start to glaze over.
The good news is there's a lot of people looking at this. All the vendors that are on, certainly Hexagon, Aviva, ourselves, Autodesk, we're all involved in these standards, in these initiatives to make it easier for each of us to talk to each other and share data, basically.
All right.
Yeah, I think Anne Marie would agree that one of the keys here is that the vendors need to be flexible enough to apply those standards with their tools, so the customers can use whichever standards they want to use.
Excellent.
It's all about the data, as we've said before, and it should not be about the systems that you use.
Yeah, and then really it's flexible. It's really going to come down to flexibility around the APIs, as they term it, right? That allow us to allow these systems to talk using a standard framework like CFOS or one of the others. And most of the vendors are really starting to push hard into that area to do just that.
So the next question is around a digital twin for a specific piece of equipment, similar to what Emily did with Braincube. And the question is around what steps do you take to make and use a digital twin around a specific piece of equipment? I'm imagining part of it is determining the model, and part of it is the data acquisition. Could you, and maybe Emily, if I could ask you, is how did you get started, and maybe talk a little bit about the steps in terms of creating the digital twin for a particular piece of equipment?
Yeah, so it really kind of starts with the basics, really defining the inputs and outputs of your process, learning the different sensors that you have on that piece of equipment to track flows, levels, things like that, really understanding what the capabilities that you have already from a fundamental level, and then implementing that so that you know that your data that you're feeding it is correct, making sure that you have all the relevant pieces of information to properly model that system. And then once you've kind of established that baseline of I can properly model this system, I have all the relevant data that I need, you can go in and use that data and establish relationships and track the performance and optimize your process. But it really does start with that fundamental process understanding and understanding those inputs and outputs and what do I have to measure and analyze my system currently.
Domain, not what I'm hearing is domain knowledge and an understanding of what kind of data you have available to use. Yeah, good point. We tend to jump on the shiny objects, the technology, and not really without a clear understanding of the environment you're trying to improve. Good, excellent. The next question is around a more live. This is again the 3D. This is more for the 3D model folks. It's around. Can that be more live? Like in the question they're asking about building a scaffolding, but I've also heard of people using it to determine the progress of the construction and actually use it for billing construction progress payments. So I was wondering if anyone would be willing to talk about the live side of the 3D model a little bit.
So I can chip in, and probably Chris can too as well. We're in the building space, we've been using our users have been using reality modeling, the running of drones on a regular basis over the same area, and creating the reality models, and then looking for differences in those reality models to track construction progress, basically. So, and typically the most frequent we've found is on a daily basis. So you run the drone, you create the reality model, you compare it with yesterday's reality model, you see what's happened, basically. And we've got several users that are using this to pay their contractors for the earth moved, for in the case of Shell in Pennsylvania, how much work has been done, etc., etc. And where they're at is comparing the reality model with the planned model. They also use advanced work packaging as well and then also track what was planned, what's actually been done, should the contractor be paid, etc. And then going up a little question above was how the frequency and fidelity of the scans to maintain models, can AI be used to keep a model up to date? So what AI we're also using, or we as a software company are putting the software to get. We're the ones who would compare the reality modelings and highlight the difference, if you like. So we've been using AI to do the same and then automatically detect changes. So it's used very extensively in tracking cracks appearing in bridges, rust appearing on telecoms towers, where you can send a drone up, but but it's really, really dangerous to send a person to that environment. So and the more you can automate that process and bring attention to the changes, the better. And we have one oil and gas company who's thinking of using the same for subsea wellheads right now, basically, and so there the frequency of doing the drones and doing the surveys depends on how quickly you think a change is going to happen. With scanning using drones and photography, you're talking a day. So it's not going to be picking it up in a minute, if you like. That's when you use real-time control systems or sensors or sensors, that kind of thing. But if you're wanting to see a slow degradation and it's difficult to keep surveying, that's when you would use scans, AI, and photography, basically.
Ralph, if I might add, so from a design and builds perspective, since we are using the twin to plan the work, right? So the planning actually comes from the model. The material takeoff comes from the model. So as your constructor progresses that work, that progress in turn passes back through into the twin. And so it becomes pretty easy to go out in the field and light up and say, show me everything that's supposed to be done and highlighted green, and then look up and see if that's actually what you see. You know, quantity surveying starts to become a little bit of an easier process when they're actually creating the plan and the materials from the model, from your twin, and then you can go out and say, okay, they said it's done. Is it actually done? Is it there? Is the box they're supposed to install actually there? Is the pipe they claimed is in the rack, is it there? You know, are the welds done? You can see if the welds are visually there. So now you're not comparing to a spreadsheet anymore. You're actually comparing to the physical asset that's there and what's supposed to be done in that asset visually, based upon the progress that your constructor has passed back to you, whether that's once a week, once a day, or more often as systems become better integrated.
Excellent. Ralph, just and also to add on to Joe and what Anne-Marie was saying, you're 100% right that again, everything's got a fit for purpose, right? And using drone technology, and if using the right drone technology, you can get really really accurate and geo-referenced models, which you can use to measure not only stockpiles but cracks on walls as well, to quantify what you see on the model. But I guess really the way to kind of also look at a digital twin in another view, or how we kind of apply, is to kind of think of a digital twin as an app store, as a central sort of platform where it's this sort of single source of information that eventually one day other companies and vendors and service providers and developers will build on little applications on top of these digital twins to solve a particular need. So right now we're really at the beginning of the pipe and making sure we're building very accurate models, be it with scanning or drones. But it's really about creating the space, and like we say, those APIs and making it easy. And we were talking about standards earlier as well, making it easy for people to build these small time applications on top of their digital twin to make them relevant today.
Excellent, thank you. While you're on the phone, Chris, and I'll be asking Joe this same question. Help me visualize how an asset is tagged. So I know you've got this photogrammetry, or you've got laser scan, point cloud, and those things are, there's no objects in there to click on and get information. So how do you convert part of that to an object that you can click on and get more information? Do you just kind of circle it and draw around the perimeter of where it is and then create an object? Is it that simple, or is there something else going on?
Ralph, it's so crazy because, I've got to maybe give you a little bit of context. So every time we walk into a room and a customer goes, I want a digital twin. So we always have to start, well, tell me, what is your concept of a digital twin? Because we realize that a lot of different customers have got a very different understanding depending on, again, what vendor or marketing that they've seen. And ideally, it's, when we showed you in our presentation, a lot of our customers are saying, well, I want this level 5, the self-correcting algorithm, machine learning, know-it-all, that if the one bolt goes missing, or if a piece of coal is too big, the plant will self-adjust to compensate for the inputs that it's receiving. So they've all see this level 5 is what they want. But you're 100% right, Ralph. You've got to start at step number 1. You've got to create the model. You've got to take all the existing engineering and, like we say, static information. So not even that dynamic and IoT and live data yet. You've got to sit there, build the model, make sure that's accurate and geo-referenced, and then say, well, show me where's all your engineering information. And then you walk into these engineering offices, and it's just piles of PDFs or paperwork or Excels. It's a lot of work creating. We shouldn't underestimate the first 2 steps of just building a 3D model and just getting the basic information there. And once you actually have it, and and that's the great thing, I guess, about digital twins, is assets are geo-referenced. You've got a GPS XYZ coordinate for every single asset that you can see, within your model. And once you have that and you can verify it, you're 100% right that it's a manual. Currently, right now, it is pretty much a manual process of drawing around assets. Sometimes you do get lucky, and like Anne-Marie mentioned earlier, there are things like flanges and valves, which, you know, one flange valve looks like another flange valve. So you can teach AI detectors to pick those up for you and sort of auto cut them out within the model, which is great. But there's a lot of assets which are very unique, and you literally do sit there and you cut around it in real time, and you start putting information. So I think, yeah, we always advise our customers, this is not a 1 year quick done, it's a rollout. It's pretty much a 3 to 5 year, take some longer journey.
And I think, Ralph, from, you know, you have to look at this, whether you're greenfield or brownfield. In this particular instance, obviously we're greenfield, which provided us with a certain advantage, right? The design tools themselves were used obviously to produce the engineering deliverables, the PDFs, the Excel spreadsheets, and subsequently the 3D model. So we have a relatively rich data-based model. Now, again, primarily focused around constructions, not so much around commissioning. And bridging that gap, of course, is what we talked about in trying to make this process better. But that rich data model, using the design tools to build that model, and then using that model subsequently to gauge the completeness of engineering and the fitness for purpose, and that it's actually going to work in the field the way that you expect when you go to operate the asset, is certainly a best practice and has been in the industry for a number of years. It's addressing all of these brownfields that exist, these plants that have been out there for 50 or 100 years maybe, and saying, well, you know, 100 years ago, we didn't have these really great tools that would create these really data-rich models. So as Christopher points out, it's a very different path to create a digital twin for an existing asset than it is to create one for one that is new. And in either case, you know, the significant challenge associated with either is, I'll get there, right? I'll have that data-rich twin. Now I have to maintain it. And oftentimes that's a challenge. You have people who have been operating a plant the same way for the last 30 years of their career, and they're used to that, the blue binder, the yellow binder, the red one, and the white one that are up on the shelf. And they're used to going in there and they'll make a field change and they'll just, you know, mark up a drawing. And in this world, it's no, wait a minute, you need to go back and make the changes in the model or the tool, and then subsequently produce the drawing so that somebody can do the work. It's very different, and getting people to move from that habit, which isn't necessarily bad, it served them well for many years, to where we want them to go in utilizing these tools and the technology can often be a challenge.
Chris, you reminded me of a mistake I've often made in my career, where I assume I understand the solution that the customer wants, or whoever I'm working with, my customer, whether it be internal or external, wants, without really having a long conversation to really get a clear understanding of what they mean by, in this case, a digital twin. I think that's pretty fundamental and something that needs to be thought through very carefully. What do you mean by a digital twin, and what problem you're trying to solve? What's the business problem, and ground what you're doing around that business problem rather than the technology that's at hand. Thank you. Well, we're just got about a minute left, so I think I'm going to wrap this up. Thank you. First of all, let me thank the speakers. Great presentations, great Q&A, a lot of good insights there, and also the help that the technology providers provided to kind of add a lot more color to those kinds of answers and the questions that came up. Thank you very much. For all those still on board, there's still quite a few of you. Thank you for sticking with us for an hour and a half, and very much appreciate your participation. Good questions that were entered. Thank you very much for listening.